Now this first lecture is quite a long one. I promise you next week's lecture is a little bit shorter, but we have one more page we need to have a look at. We need to talk about multiples and factors. What do they mean? I've used the word multiple quite a bit. I haven't used the word factor yet. What's a multiple? Well, a multiple of a number is obtained by multiplying it by any other number. We've talked about multiples of 10, multiplying any number by 10, and that means we add the appropriate number of zeros. So if I write the number 3 and I want to find its multiples, 3 times 1 is 3, 3 times 2 is 6, and 3 times 3 is 9. 3 times 4 will be 12, 3 times 5 will be 15, 3 times 6 will be 18. All of these are multiples of 3. If I look at the number 4 and look at its multiples, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, the next one will be 4 times 5, which is 20, 4 times 6, which is 24, and so on, going up by 4 each time. Now the question that you're going to be asked is to find the least common multiple of two numbers. So if we're looking at the two numbers 3 and 4, the least common multiple of both, that is the lowest number that is common to the multiples for both, is 12 and 12 there. So let's just circle them. So the answer to the question is the least common multiple of 3 and 4 is 12. So we've talked about multiples, that's fine. Let's now look at factors. What do we mean by factors? The factors of a certain number are the numbers which, when multiplied together, equal that number. So for instance, if we look at the number 6, we can write it as 2 times 3. 2 times 3 are factors of 6. But if you think about it, 6 is also equal to 6 times 1. So 6 times 1 are also factors of 6. If we look at the number 12, what are its factors? Well, for the number 12, can be equal to 1 times 12, can be equal to 2 times 6, so 2 and 6 are also factors. It can be equal to 2 times 2 times 3, so hence 2 times 2 times 3 are also factors. So all the factors of 12 are let's do an arrow there, 1 and 2 and 3 and 6. Is there one I've forgotten? I think there is, isn't there? What if you multiply 2 by 2? 2 by 2 is also a factor of 12 because we can write 12 as 4 times 3. So 4 is also a factor. Okay, so that's what we mean by the factors of a number. So you've got to get in your mind clear the difference between multiples and factors. Multiples is when you multiply a number by another number, but a factor is when you break up a number into the numbers which will multiply out to that number. A bit confusing, isn't it? Let's now move on to prime numbers. Does anyone know what a prime number is? A prime number is a number which can only be divided by itself and 1. So for instance, the numbers 1, 2 and 3 are all prime numbers, because they can only be divided by themselves and by 1. If we look at the next number, which is 4, well, it can be divided by 1, but it can also be divided by 2, so hence it's not a prime number. So the next prime number here will be the number 5, because you can't divide anything into 5 except 5. The next prime after that will be not 6, because 6 can be divided by 2 and 3, but 7 is the next prime. And if you want to keep going, you can keep going to infinity here if you like. 8 and 9 are not primes, neither is 10, but the number 11 can only be divided by itself and 1. Okay, so now we need to move on, and what we're going to try to do now is find the factors of, or the prime factors of, two numbers. So the question is, find the prime factors of 56 and 500 and write each number as the product of its factors in power notation. So how do we do that? Let's start with the first number, which is 56. I begin by looking at the prime numbers only. I know that 1 times 56 is 56, but that doesn't really get me anywhere. So let's now look at the next prime number, which is 2. Does 2 divide into 56? It does. 2 times 28 is equal to 56. Does 2 divide into 28? Yes, it does. 2 times 14 is equal to 28. Does 2 divide into 14? Yes, it does. 2 times 7 is equal to 14. So what you can see now is that I've only got factors here that are prime numbers, and they are all down the left-hand side. So 2 times 2 times 2 times 7 is equal to 56. So written as a product of its prime factors, we can write 56 is equal to 2 cubed times 7. Let's have a look at 500. Look at the first, or the lowest prime number, 2. 2 divides into 500 twice. 2 times 250 is equal to 500. Can we divide 2 into 250? Yes, we can. 2 times 125 is 250. Okay, 125. It won't be divided by 2. So what's the next prime factor, or next prime number, is 3. Does 3 divide into 125? Well, no, it doesn't. What's the next prime factor? It's 5. Does 5 divide into 125? Yes, it does. 5 times 25 is 125. And then prime factors of 25 are 5 and 5. Notice that we have all the prime factors down the left-hand side of this factor tree. And we also did on when we looked at 56. All the prime factors down the left-hand side and along the bottom. So we can now rewrite our 500 as 2 times 2, which is 2 squared, times 5 times 5 times 5, that's 5 cubed. And the very last thing we want to do in this lecture is to find the highest common factor of two numbers. So I'm going to show you another way of writing down the factors of two numbers. So for instance, if we take the number 24, let's get the pointer working, 24 is equal to 1 times 24. Looking at the next prime number, which is 2, it's equal to 2 times 12. The next prime is 3. 3 divides into 24. 3 times 8 is equal to 24. 4 divides into 24. 4 times 6 is equal to 24. So what I have written along the top line here are all the possible factors of 24. Can I do it for 60? 1 times 60 is equal to 60. Look at the next prime. 2 times 30 is equal to 60. 3 times 20 is equal to 60. 4 times 15 is equal to 60. 5 times, does 5 divide into 60? Yes, it does. 5 times 12 is equal to 60. You can barely fit these last two in. 6 times 10 is equal to 60. Now this process is quite important for when we get to fractions, doing operations with fractions. The question is, what's the highest common factor of 24 and 60? So we're looking for the highest factor of 24 and 60. It's got to be common to both, and you can see quite quickly that it is 12. So the highest common factor for 24 and 60 is 12. I think that brings us to the end of the first week, which was looking at operations with positive whole numbers, the positive integers. Next week we'll be looking at the negative integers. Goodbye, I'll see you then.